Let's talk a little bit more about databases and SQL. A lot of different things can be referred to as databases. So for example, if you've got a list of files on your computer, that's a database of files. If you look at the contacts on your phone, that's a database of contacts. What we're talking about in this course, though, is actually more than that. We're talking about database management systems, or DBMSs. And DBMSs can do a whole lot more than just storing and listing data. One thing DBMSs do very well is let you store and query very large amounts of data, terabytes of data, and they do so in a way that ensures that the data remains consistent and error-free. Databases also take care of concurrency for you, which means multiple people, or maybe processes or threads, trying to read and write data at the same time. Again, that can be something that's very tricky if you're just talking about plain text files. Databases also have ways to deal with user permissions and access. So if you only want some users to have access to certain tables, or some other users to only have access to a certain database, that's something you can do with a DBMS. You can typically also manage things like replication and backups, and they also often expose programmatic interfaces, which means that you can talk to the database using your favorite programming language, like Python or Java. So DBMSs, like Postgres, which we're using in this course, are far more than just containers of text files. And it's for this reason that your favorite website is most likely using a DBMS behind the scenes, rather than just storing all their user data in plain text files. In relational databases, data is stored in tables, which are also sometimes known as relations. And this is not too dissimilar really from, say, an Excel spreadsheet. But the data is stored in a way that has minimal redundancy and ensures that data integrity is maintained. The relational model requires that we break up our data into entities that are each stored in their own table, and we do this via a process known as normalization. This is fine and works well for a variety of different applications. There are other circumstances, however, where this presents a bit more of a problem, and this is where non-relational databases come into the mix. So for example, if you've broken your data that you wanted to store up into multiple different entities, which are each stored in multiple different tables, when it comes time to do some future reporting, you have to go through a process of rejoining all that data, sometimes called denormalizing your data. Depending on the size of your data, that can be a very expensive operation. Sometimes as well, it's just inconvenient to have to break up your data into multiple different tables and then constantly reassemble it. Sometimes that doesn't even make sense for the kind of data that you're trying to store. So non-relational databases grew out of a desire to address these problems. You'll sometimes also hear them referred to as NoSQL databases. And you might hear people talking about things like key value storage, or document storage, or graph databases. These are all types of non-relational databases. Incidentally, they're called NoSQL databases because more often than not, you don't actually use SQL to work with that database. Though more recently, SQL is becoming much more common even in the non-relational world. Often, you look to these more esoteric kind of databases when you have more specialized needs. But for most applications, almost everybody has a regular relational database humming away in the background. We can use relational databases for more than just storing and retrieving data. For example, we can ask databases to do all sorts of calculations internally before giving us the answer back. So if you have a database, for example, where you're storing the sales for your business, you can ask the database to sum over the full lifetime of your sales and tell you how much you've made, even if that consists of millions and millions of records. That's no problem for a database. We can also search through millions and millions of records for entries that are from a specific time range. Again, no problem. You can also do all sorts of interesting aggregations with a database. So you can use it to, for example, generate a report of sales by employee by month, rather than asking the database to return you all the records and then doing that sort of aggregation in an Excel spreadsheet. So databases enable you to do all sorts of rich and interesting data analysis. And this gives rise to people using databases for investigative analysis and data journalism. Okay, so we've covered the backstory. Now let's finally talk about what we came here to learn. SQL. SQL, or SQL, stands for Structured Query Language, and it's a programming language designed to query and manage data in relational databases. There are several categories of statements that make up SQL. So SQL can be used to create tables, to alter tables, and to delete tables. SQL can be used to work with the data within those tables. So you can use it to select, insert, update, or delete data that's within a table. And SQL also has a class of statements which you can use to deal with granting and revoking security permissions. For this course, what we're going to focus on are the first two parts. So we're going to focus on the statements that are used to create, alter, and delete tables. And we're going to focus on querying the database and inserting and updating and deleting data. SQL is both ANSI and ISO standardized. It's a standard language, and there's a spec that's available online that you can get access to and read. It's also a non-procedural language. So to contrast that against a typical programming language that you might have used, like Java or Python or C++, those are all examples of what's called procedural languages. In those languages, there are branching statements, there's looping constructs, and in those languages, we write code that defines a sequence of steps that the computer then carries out and executes. With SQL, however, it's a non-procedural language. Sometimes it's also called a declarative language. And what we do with SQL is we define what we want the computer to give us. We define the inputs and we define the outputs. And we say, look, you take care of figuring out how to execute that. You look at the table structure, you look at my indices, you figure out what's the most appropriate execution path to give me what I want. And the component that does that is called an optimizer. And we'll talk about optimizers a little bit more in this course later on. So in this course, we're going to be using the Postgres dialect of SQL. What you find is that even though SQL is ANSI and ISO standardized, different database vendors have implemented their own dialects or their own variations of SQL. Most database vendors have done a pretty good job of following the standard. However, what you'll find is that some haven't implemented all of the standard, and in other areas, you'll also find that they've implemented even more than the standard. So different database vendors have implemented different keywords, new functionality, and additional things on top of SQL. Generally speaking though, we won't worry about that too much for this course. Everything that we learn in this course will apply to other databases as well. What you'll find is that there's some minor syntactic differences and some slight variations on what's possible. With some databases, there's faster and more efficient ways to do things, and with others, it won't work as fast. But the emphasis of this course is on concepts and problem solving. And so what you learn here, you will be able to apply regardless of whether you're working with SQL Server, MySQL, or any other database. Because SQL is a non-procedural language, that means that by default, it doesn't have some of those richer language features that you might expect if you've come from a background of working with Java, Python, etc. So out of the box, you won't find, for example, that you've got looping statements. However, depending on the particular database that you're working with, you might find that you come across PL/SQL or T-SQL, which are non-standard SQL extensions with procedural elements. T-SQL is the language that you use when you're working with Microsoft SQL Server, where the T stands for transact. PL/SQL stands for procedural language for SQL, and it's the language that you use when you're working with an Oracle database. These languages are more fully featured variations that include procedural programming aspects like local variables, loops, and control structures. We won't really be going into those things in this course because A, they're quite advanced, and B, it's very, very vendor specific. Additionally, while you can of course write more complex apps and scripts using these procedural additions, it's my recommendation that in general you'll be better served instead working with a traditional and richer programming language like Java or Python, and using that to execute simpler SQL statements from your code and maintain all your traditional logic there. This is the way, for example, most mobile, web, and desktop applications are built today. Okay, we've got one more little bit of theory to get through, talking a bit more about the relational model and how tables are structured and defined, and I'm going to introduce you as well to our sample database that we're going to be working through this course, and then we'll dive into writing some SQL.